Hello and welcome to the last lecture. In the last lecture here, we're going to be covering additional authentication methods, a few extra secret engines, walkthroughs, along with explaining what AppRole does and how it can benefit us. So first, I've set my autoscaling group back up to a desired of 1, which will allow for at least one instance running that will allow for Vault to start. As you can see on my screen here, I have in this case, running a T3A Nano of just the instance. In most cases, I can run up to 3 or however many you may need to handle the incoming load for Vault. Once it started, I was able to log in using my root token in this case. And otherwise, you can enable LDAP and different types of authentication methods to allow access to both yourself and your team. In this case, I have a few secrets engines created here. You can see a few test AWS secrets engines, which I've used for identity and access management creation. They have a policy ARN attached to them in most cases. In this case, data scientist. And I'm generating keys here. And for anyone who's watching this video now, don't worry, those keys are being deleted. Not that you were able to see the other half of the secret access key anyways, but they're not able to be accessed. For every deployment, there's something called a cubbyhole, and a cubbyhole is a key value store for each user, which can be used to put in place a key and then a value of that key for key store use for personal use. HashiCorp Vault also supports Azure and Google Cloud Platform for access creation, much like AWS. We won't go into it in this course, but Vault does have documentation covering the setup process of that. Next, I'm going to cover app roles here. I've already enabled the AppRole authentication method. And what AppRole does is, for example, we have a instance that requires identity access management access keys and secret access keys and needs to retrieve them securely. So for example, we have some type of scheduler that needs access to store a report in S3, but we need to store those keys securely, and we can't use identity access management roles because it's outside the environment or any other circumstances. So what it does is we have a scheduler, say on-prem, written in Java. You can make an API call to Vault API, which I actually will provide in the course. It's actually written in Python. So if for Java, I have another variation, but in this case, it's written in Python. Makes an API call over HTTPS. Securely, actually TLS, over port 8200. Once the API call for AppRole, it provides the secret and the secret token, role ID rather, the secret role ID. And once it provides that, Vault will grant a token. And then on your scheduler on-prem, we'll respond back with the token to log in via API. So it's going to be that TCP 8200. And then once it responds back, the Vault will respond with, in our case, when using AWS secret, the secrets method, AWS and secrets engine, will respond with an access key and secret access key. And that will be valid for the lease TTL. So in most cases, it's 30 minutes or 4 hours. Those access keys can then be used to grant access to the environment, place that file in S3, and then after 4 hours, The schedule on-prem can run a scheduled task or a cron or some similar type of fashion to request a new token, which then it can use that token to send back to the API to grant a new access key, a secret access key, for however long the max duration is. So that's valuable for any additional applications that you may have that may require access where you don't want to manually run the process of logging using the user interface, or making the API calls in the application itself. So that pretty much covers the additional method, the AppRole method. There's many more authentication methods, which include LDAP, username, pass. It also supports Kubernetes secrets. Again, I won't get into that in this course, but please join me in the Q&A section for any questions, and I can gladly answer them. Thanks.